All right, calculus folks, or discrete math folks. This is our day 3 of set theory, and we're going to learn some operations finally, called union and intersect. You actually kind of know these already if you've ever done Venn diagrams, which we are going to do next week, or next week, we're going to do tomorrow, the next lesson. And basically, it's like and or from logic. That's why I like that we did logic first, because intersection is the first one we're going to do. So intersection. Okay, I'm going to pause while I write this here. All right, so our first vocab word we're going to do today is intersection. Intersection is just easier for people to grasp because it's like it sounds. First of all, the symbol for it is like an upside down U. Some people like to think of it like an N for intersection, but then that just gets confusing because union, well, has N's in it too, so I don't know. But long story short, it's like the word and. And in statistics and in logic, remember how our and? Well, I'll write and. Yeah, so it's like and remember our old symbol in logic for and was just a sharper version of this, right? It was an upside down V. This one's an upside down U, which is a little curvier, but it still means the same thing. So A intersect B is a set of all elements that are both in set A and set B. That's why it has the and right there. Intersection is only the overlapping elements. So if we go back to sets, remember sets are written with curly braces. That was a pretty good one. Let's say set A was 1, 2, 3, 4. And set B was 3, 4, 5, 6, 7. Now you could do the whole, we've tried subsets and proper subsets and equals and complements and universe and empty set and all that stuff. Now we have a new action. I can take set A and intersect it with set B, and the result is just where they overlap. So if you look at it, remember, these don't have to be in any certain order, but they both have a 3 and they both have a 4. There are no other elements that overlap between them. So the intersection, or the overlap between them, is 3, 4. It's a new set. It's called A intersect B. Okay, so that's what intersection looks like. When we do Venn diagrams next lesson, we'll just have a visual for this exact same thing. Okay, so another one is union. So its symbol is the right side up version of that, which looks like a U, so it makes sense that it's called union. It's the or one. If you were doing statistics or logic, the idea of union is or if I were doing logic, I would have this. Okay, and union is the set of all elements that are in set A or set B or both. So basically it's a collection of all the different distinct elements. Distinct is a better word than different. Okay, so yeah, I mean, you have the word and here, you have the word or show up a couple places here. That's how you want to think of it. Intersection is and, union is or. Okay, so for this, if I used my same A and B as up here, so I don't have to rewrite it, if I wanted A union B, it's going to be the set of all numbers that are in either A or B or both. So I start with, 1, 2, 3, 4. I don't need to rewrite 3. I've already written that element. It would be redundant to say it again. So you don't repeat writing them. You're just kind of making a collection of all the different things you see. So I saw 1, 2, 3, 4. Don't need to repeat these 3, 4. And then 5, 6, 7. Okay. I'll put here, don't write repeated elements more than once. Okay, so now we have some actions. Remember when we had truth tables and we finally learned how to and or and implies and stuff? Well, now we can actually do some stuff with these, which is pretty good. Okay, so let's start a new thing here. Okay, so we're going to start doing an example, and we're using the same A and B as before when I defined them. Then we're adding a third set C, and now we're going to get used to using the complements, a universe, parentheses, union, intersect. So it's just an example to get used to this stuff. Okay, remember this is a bold U, so it means the universe. So for our universe that we're working with, their numbers 1 through 10, integers 1 through 10. A is 1, 2, 3, 4, B is 3, 4, 5, 6, 7, and C is 9, 10. So if I wanted to do A naught unioned with B, remember union means or, but I like another phrase to help people learn this, because most people intersect or overlap works really well. But for this, another phrase I like with these is along with. That's how I want you to think of a union. Everything that's in A naught along with everything that's in B is going to be my final set. Okay? So if it helps you, some people can do this in their brain. They can say, okay, here's A, 1, 2, 3, 4, and here's my universe, so I can know what's in A naught. But if it helps you to write it down, you know, especially when you first start doing these, wow, that's a terrible curly brace. Especially when you first start doing this, think, okay, here's my universe, here's A, so A naught must be 5, 6, 7, 8, 9, 10. And I'm going to take that guy along with this guy and just combine everything that's new, right? So I want to pair them together. I'm not going to write repeats. So the lowest number I see, just to keep track of things, not that order matters, but I see a 3, and I see a 4, and I see a 5, and a 6, and a 7. Okay, oops, lots of commas there. I don't need to repeat the 5, 6, and 7, but I do have these new items, the 8, 9, 10. 8, 9, 10. So the set of everything that's not in A along with, or union with B, is 3, 4, 5, 6, 7, 8, 9, 10. Okay, now let's try this one. Let's try an intersect, right? Remember, intersect is overlap. I want to see where these two sets overlap. So where does B naught intersect with A? Well, I don't know. Maybe it might help you to write B naught down. You know, it's like doing your work in truth tables. So if B is 3, 4, 5, 6, 7, then B naught is everything in the universe that's not 3, 4, 5, 6, 7, which would be 1, 2. I skip 3, 4, 5, 6, 7, and I go 8, 9, 10. So that's B naught. Where does this thing intersect with A? What do they have in common? Well, the 3 and the 4 don't show up in both, but the 1 and the 2 do. So it's just 1, 2. Okay. The third one is, where does C overlap with A? So I look at these two. I don't have to do any knots. 9 and 10, what do they have in common with? What elements do they have in common with 1, 2, 3, 4? None. Okay, so you have two ways of writing this. You can write it like this, they got nothing in common, or, my favorite, the empty set symbol. If two sets have nothing in common, they are called disjoint. These two sets are disjoint. That's a vocab word, right? Okay, couple more. I can do this a couple ways. I'm going to do one of these using DeMorgans Law and one of them not. Okay, so if I want A union B not, one thing I can do is just find regular A union B and then do everything that's not in it. So let me do it that way for this one. Okay, so A union B is collect everything, right? It is along with everything in A along with everything in B. So I'm going to go 1, 2, 3, 4. I don't write any overlaps. 5, 6, 7. Okay. And then I want everything that's not in here. So if that's A and my universe goes 1 through 10, then A union B not is just 8, 9, 10. Now I could have done this the other way I'm about to show you, and that is, remember DeMorgans Law kind of said, I'm allowed to distribute this not into all these. It was something in logic. It's called DeMorgans Law. And I could do the intersection and then take the not, but I kind of want to do this a different way. I want to say, okay, wait, that's the same as A naught unioned, because it changes the A, it changes the symbol from an intersect to a union, and it changes the B to B naught. It's called DeMorgans laws. Now I can put together everything from A naught along with everything from B naught. Now if you remember, here's A naught, here's B naught, right? I'm going to union them together. That means collect everything new. So that would be a 1, a 2. I don't see a 3 or a 4, but then we got a 5, a 6, a 7, 8, 9, 10. I don't need to put any repeats. So that is the equivalent. Guarantee if you found where they crossed, which was 3 and 4, and you took everything that's not 3 and 4, you get the same answer, right? And last one, C intersect A not. We already just found C intersect A is nothing, right? Well, what's the not version of nothing? It is everything. So I could write 1, 2, 3, 4, 5, 6, 7, 8, and 10, or if I'm feeling lazy, I could just write bold universe, right? Universal set. And sometimes we use dot dot dots because we don't feel like writing everything. All right, let's do one more example. Just kidding. That was enough examples. So forget that. All right, good deal. We'll talk to you later. Hope that makes sense. And yeah, good times, man. Adios, people.